yes.
Okay, go ahead.
Okay. Good afternoon. My name is Jae Jung, and today I will give a lecture about ocean renewable technology, energy. So this is the contents for today's lecture. And from these contents today, I will mainly talk about wind energy. So you will start from the definition of renewable energy. Renewable energy is a energy that are collected from renewable resources. And renewable resources are energy that is naturally replenished on a human timescale. And examples for these renewable energies are sunlight, wind, rain, ocean tides, and etc. For example, for wind energy, solar energy, the energy is replenished within a day normally. And for geothermal energy, the energy is usually constant, so it never runs out in a short time frame. On the contrary, there are non-renewable energy, which are energy that are not replenished within a human timescale. For example, there's coal, gas, and uranium, and all of these energies does not replenish in a human timescale. So where does wind energy gets its energy from? The answer is our sun. Our sun
Oh, we lose the connection. It's coming again. No. We can wait a little bit for the reconnection of Jeuk. It's coming.
Can you hear me?
Yes, we can hear you.
Yes, sorry, my internet connection is not stable, so I will keep on going. To start again, so our sun radiates a lot of energy into space. The exact amount of energy it radiates throughout space is calculated to be about 3.86 times 10 to the 26 watts, which is a lot. But most of the energy is radiated on other directions rather than Earth. So the exact amount of energy that actually reaches Earth is only about 1.74 times 10 to the 17 watts. So the wind is a byproduct of solar energy. So wind is produced. So like I said, only a fraction of the energy reaches the Earth's surface, which is about 2% of the total energy that reaches the Earth. So, but due to the distribution on water or elevation on the terrain, not all surfaces on Earth are evenly heated. And you can see in this figure on the bottom right, this is a map of a direct normal irradiation of the Earth's surface. We see that due to the various factors that I just told, the surface of the Earth is heated differently, and this temperature difference causes the wind. So we will watch a short video explaining why and the mechanisms of how the wind blows.
Jeuk, sound is not coming. You need to share the sound option. Can you go out and unshare and share again using the audio option checkbox?
Can you hear this?
Differences.
Yes.
Why does the wind
Yes.
blow? Wind is part of weather that we've all experienced at one time or another. And whether it's a welcome breeze on a hot day or a destructive gust during a storm, it all starts in the same way. Differences in air pressure. Air is a mixture of gases in Earth's atmosphere. The weight of these gases pushes down on Earth, creating air pressure. How does air pressure cause wind? Wind is caused by differences in air pressure, and temperature can affect these differences. Gases are made up of tiny particles called molecules. When gas molecules in our atmosphere are warmed by the sun, they do three things. The molecules move quickly, they spread out, and they rise up. As warm air rises up into the atmosphere, it isn't pushing down on Earth quite as much. This creates an area of low air pressure. When gas molecules are cold, they do the opposite. They slow down, move closer together, and sink. As cold air sinks down in the atmosphere, the weight of the air pushes down on Earth's surface a bit harder. This creates an area of high air pressure. The sun doesn't heat all of Earth equally, so there are high pressure areas and low pressure areas all over the planet. In general, air always flows from an area of high pressure to low pressure. So, cool air in high pressure areas will rush into the low pressure area created by rising warm air. This rushing air is called wind. Why is some wind a gentle breeze while other wind is a strong gust? The strength of the wind depends.
Okay, so this is the end of the first video. To continue, so why do people use wind power? The advantages of wind power comes from the low price. Wind power is one of the cheapest ways to produce energy, as can be seen on the figure on the top right. We see that the price of wind is about 50 megawatt hours, which is very low compared to like conventional methods such as gas, coal, and natural gas. And the price is also similar to solar panels, which is another type of renewable energy. And also the supply of wind energy is relatively stable compared to solar energy, and it is very abundant compared to other sources, which I will show you in another figure in the next slide. So thanks to these advantages compared to other methods, the more wind power technology is developed and installed every day. And the latest trend for wind power turbines can be summarized on the slide. Wind turbines today, they are developed to be, the blades of wind turbines are developed to be more lightweight, and they are also developed so they have more flexibility, so they can withstand more harsh weather. And also the diameters of each blades tend to get larger because the larger diameter blades tend to be able to harness more wind power. And also, as we can see in the figure on the right bottom right, they now tend to have the capability to flex and bend. So this is a figure of the global energy potential of renewable and non-renewable energy. Like I said, wind energy is very abundant. It has a energy potential of about 25 to 75 terawatts, which is much larger than the current world consumption energy, which is about 16 terawatts. And it is also comparable to the total reserve of non-renewable energy, such as coal, uranium, oil, and natural gas. So because of the abundance and the advantages that I just mentioned, lots of countries, including Korea, are utilizing wind power to power their power grids. And Korea actually has a lot of wind resources too. We can see that the average wind speed of Korean onshore and offshore is about 7 meters per second. And there are lots of wind power stations throughout Korea, as you can see on the figure on the right. And all of the power generation capacity in Korea, they add up about to 1.6 gigawatts currently. So these figures on the bottom left is an example of the wind farms that are currently installed in Korea. So how does wind turbines work? So wind turbines are simply they are devices that convert the kinetic energy in the wind into mechanical power, or to be more precise, electrical energy. So in order to do this, the blade of a wind turbine turns the kinetic energy into rotational mechanical energy. And this rotational energy is converted into electrical energy via the generator. And when energy is produced, they are transmitted to households near the wind farm, like on the figure on the right. So we'll watch a second video explaining how wind turbines work in more detail.
How does a wind? We are going to show you how a wind turbine works. Each wind turbine has a wind vane at the top that indicates the wind direction. This allows the turbine to rotate on the tower and face the wind. The blades also rotate on their axis for maximum resistance. Wind force, that is, the kinetic energy contained in moving air currents, spins the blades. These are designed to fully capture its energy. They can be as long as 60 meters each and are made of very light and resistant materials for ease of movement. This is why they can produce energy even with very light winds, starting from about 11 kilometers per hour. With very strong winds, above 90 kilometers per hour, the blades are placed in the feathered position and the turbine stops spinning for safety reasons. The blades are attached to the wind turbine through the hub, which is coupled to the low-speed shaft. The low-speed shaft is given this name because it spins at the same speed of the blades, between 7 and 12 revolutions per minute. To produce electricity, it is necessary to increase the turning speed of the low-speed shaft. That is the mission of the gearbox, which raises the speed over 100 times and transfers it to the high-speed shaft. The high-speed shaft, that rotates at up to 1500 revolutions per minute, is connected to a generator. The generator converts the kinetic energy into electricity, a source of energy that is easier to transport and use. The electricity produced in the generator is conducted through the interior of the tower to the base. There, a transformer raises the voltage for transport inside the wind farm. From each turbine, alternating current is sent to the substation through underground cables. Here, the voltage is increased again to feed it into the power grid and transport it to end consumers. This is how we use the wind to light cities, feed industries, schools or hospitals, or operate our household appliances.
So we watched the video how wind turbines work. So next we will talk about the types of wind turbines that the two main types of wind turbines. There are two types of wind turbines, which are vertical axis wind turbines and horizontal axis wind turbines. For horizontal axis wind turbines is a wind turbine where the rotation of axis for the blades are perpendicular with the ground. So it is the type of wind turbine that we know best of. And the second type of wind turbines are vertical axis wind turbines. Contrary to the horizontal axis wind turbines, they have a rotation of axis that is perpendicular to the ground. So due to these characteristics, there are several advantages and disadvantages for vertical axis wind turbines compared to the horizontal ones. So the main advantages is that since the rotation of axis is perpendicular to the ground, there is no need for wind tracking. And also, since the blade speeds tends to be lower than the horizontal axis wind turbines, they cause less noise, and they cause less environmental concerns. The main disadvantage for vertical axis wind turbine is that they have lower efficiency because, like I said, they rotate at a slower velocity than the horizontal counterparts. So this is the final video comparing the vertical axis wind turbines and the horizontal axis wind turbines.
What to choose? Vertical or horizontal axis turbines? When you imagine a wind turbine, you probably think about something like this. But there are other designs out there, like the vertical axis wind turbine, or VAT in short. The Savonius model is very crude and was already used by the Persians 3,500 years ago. Then there is the Darius model, with blades revolving around a vertical shaft. Each blade gets hit by the wind at a different angle. They make use of an airfoil design, so they generate lift to make the turbine rotate. A generator at the bottom of the structure converts the kinetic energy into electricity. The VATs are omnidirectional. They do not need a yaw mechanism to be pointed into the wind. Also, compared to horizontal turbines, VATs can be grouped closer together, because they can operate in a turbulent and gusty wind. So why don't we see more VATs then? Well, VATs tend to be less reliable and less efficient than horizontal turbines. This makes them less suited for large-scale energy production. But the field is still under development, so who knows? We hope you enjoyed this short lecture.
So the final thing that I want to mention in this lecture is the general evolution of blade size and the power production capacity of a single wind turbine. As you can see in the figure, compared to the past, wind turbines are getting larger and larger as time passes. And we also see that generally offshore wind turbines are much larger and have a higher power production capacity than land-based turbines. So we can see in the figure in the current day, a average land-based wind turbine has a power production capacity of 2 megawatts and have a rotor diameter of about 100 meters. To give you an idea how big a single wind turbine can produce, I have brought an example comparing a nuclear power plant to a wind turbine. So the picture of a nuclear power plant is actually a picture of a Gori 원자력 발전소, which is a nuclear power plant in Korea. And if we search how much power a single reactor produces, you can see that a single reactor produces about 1,000 megawatts of power. So comparing this to wind turbines, we see that wind turbines are expected to produce about 10 megawatts of power per turbine. So we can see that about 100 wind turbines can produce one nuclear power plant worth of energy. So this is the end of today's lecture. I apologize for the hiccup on the first part of the lecture. If you have any questions, please feel free to ask.